me.
Okay, look, everybody needs to watch this one. Huge key. Carly did this part right, so I'm going to pay her a ticket just to start with. They give you a formula for velocity. They ask you to identify the maximum acceleration. So Carly correctly remembered the acceleration and the derivative of velocity are the same thing. And she said, I'm going to create an equation for acceleration. This is another great example of you can't just manipulate your way through the problem. You've got to understand what you are actually accomplishing with each step. So now I have an equation for the acceleration. Someone else who'd like to earn a ticket who's willing to talk with me for a few moments? Need a hand. Let's go, Isaac. Thank you. So Isaac. When I have an equation in front of me, I need to keep track of the purpose of that equation. Okay. What is the purpose of this equation?
So, position on your acceleration graph, picking right there, the blue.
Say it again, Isaac.
So on your position for your acceleration graph, that's the equation that'll give you your points on your acceleration graph.
Oh, I like that. Yeah, if I was trying to make a graph of acceleration, this equation would definitely give me all the coordinate points I need for my acceleration graph. It's perfect. What's the goal of the problem, Isaac?
I'm just trying to find the maximum acceleration on the interval 0 to 3.
Which is like saying, I've got a bunch of acceleration values. Beginning at time equals 0, I know some acceleration. In fact, I can find that. What's the acceleration at time 0, Isaac? Do you have any questions? Oh, please.
You actually put T behind the
What did I do wrong? Oh, thank you. I made a huge error. Well, Harley had a well-earned ticket because she found my error.
Can you just say full class ticket?
Oh, that's Mr. Repti's slogan there, so.
Can't take this.
I don't want to steal his slogan.
Yeah.
So.
My retail.
So his tickets are a lot less valuable. On the dash.
So this is wrong.
12.
What goes here?
12.
12. Okay, we have a question. We're not following the idea. Like, don't follow the manipulation.
So you have A of t equals b prime of t. I'm confused why we're going to A of t when we are just given the v of t. Couldn't we do it all with just v of t? Not use.
I'm going to try and get you to see the answer to your own question. What's the goal of the problem?
Find the maximum acceleration.
Right. So, maybe I'm probably not asking a very good
Oh, I
question.
think I get it.
So to
we're
me,
given-
it's like, if I'm going to find the maximum acceleration, I probably need the acceleration.
Yeah.
Does that make sense?
And we're given this velocity, so we have to turn velocity into acceleration.
Yeah, it's, hey, listen, look at me, look. This is a very common thing on the AP test. They will always create questions that will force you to understand, not just do. And that's why they give you velocity. Because for students who are just doing, they'll fall into that trap, right? They'll just say, oh, I take this equation, I do something to it, and I get an answer. And sure enough, one of these will be the answer that goes with that. It just won't be the right answer. Please.
So for the acceleration equation, couldn't you see that there is a square in the first little bit, and then know that you just need to plug in the maximum number you can for t, because it's being squared exponentially? That'll mean it always goes up.
The problem is this. It's what Caleb suggested, partly correct, is that because A in this case is a quadratic, Caleb knows that A will look like this in general. What you don't know without more analysis is we're only interested in the interval 0 to 3. So what if 0 happens to be this value and 3 happens to be this value? That certainly the highest acceleration would not occur at 3. Does that make sense?
Yeah.
Plus, I think it's better to learn a method that works for whatever equation they give us. Like, I don't want to learn a method that only works for a quadratic. I want a general method that will work for anything. But good comment. You good there? So back to where we were with Isaac. I haven't paid your ticket yet. Yeah, you're still eligible for a ticket. So we got to find out, of all these different accelerations here, which acceleration is highest. But we're only looking for those that land between time equals 0 and time equals 3. So one of these accelerations will be the highest. Now, there's two ways you can go here. The way Carly went is a very good way to go. There's two ways. You can remember what I taught you about what's called the candidates test. The candidates test says, despite the fact that there are an infinite number of times between time 0 and time 3, in reality, only a few of them matter to me. All I care about are the beginning time, the final time, and any critical times in between. So Isaac's turn to speak again to get his ticket. I need to find the critical values, critical points, critical times of the acceleration. How do I find the critical times of the acceleration graph?
Don't you see where the acceleration graph is 0 undefined?
Close. Ticket for Isaac. Somebody else who hasn't earned a ticket, if you can tell me, like, correct his error, I'll pay you. We might have to talk to you for a few more moments, but anybody wants a ticket hasn't got one yet? Mike has got one already. The question is, the min-max theorem says A is going to be highest. A is going to be highest.
No.
Grab the pen first. A is going to be highest at the beginning time for the interval, the ending time of the interval, or at any critical time of A. So we need the definition for finding the critical point of A. April.
Wouldn't it be any time that, any t value that would make a equal 0 or undefined?
Stay with me. That's exactly what Isaac thought. That's a mistake. No worries. That's just misremembering. Anybody else remember the definition? You've got tickets already. You've got a ticket already. Looking for those who are ticketless. Help her out, Carly.
So it would is the derivative of the acceleration that you can find.
Yeah, so on your reference sheet, the white one you got in first term, unit 1, it says any function has a critical point where that function's derivative is either 0 or undefined. So we must have a prime, which can be found quickly. So a prime is 6t minus 6. That's how we find the critical points of A. So April, stay with me. So now we fix that error. Can you tell me, April, what would be the critical times associated with A?
It would be positive 1, right?
Perfect. T equal 1 is the only time that when plugged into A prime, I get an A prime of 0. So that's the critical time for A, which means I only really am concerned with 3 times here, 0, 1, and 3. You are guaranteed that one of those times will be the highest value of A. You are also guaranteed that one of those times will be the lowest value of A. Don't leave on the bell. Avery. Go ahead. Don't leave on the bell.
After this, would we make a sign chart to find out?
We can. A sign chart is a good way to go. Another way to go is to just say, I don't really care. Let's just go test them. Like either way is fine. But another way to do it is to just plug in 0, 1, and 3 and see what you get. What do I plug 0, 1, and 3 into? A, because I'm trying to find where A is greatest. This is a really good example of, again, if you don't understand what the equations mean and why you're using them, I've seen students get so confused. They're like, well, I've got B, and I've got B prime, and I've got B double prime. Which one do I use? We actually use all of them for something, but you've got to keep track of what goes where. So now I would simply plug into acceleration a time of 1 and a time of 3. Have you done that by chance?
Yeah.
What did you get for 1?
Well, actually, I plugged in the wrong equation.
Oh, gotcha. So you did that same thing where you, I grabbed the wrong one. So no big deal.
3, 3, and 9 out of 1.
Put 1 in here, what do you get? 9.
And then
3 is 21. So we have found both the absolute min and the absolute max of the acceleration for that time interval. The highest acceleration is going to be 21. The lowest is going to be 9 for that interval. Good work.